Hello students, welcome back to our YouTube channel. I'm your host, Human Creator. So today we are going to talk about last class we talked about we created a program and how to running a program. Today we are going to talk about expressions, and in expressions we are going to start with the data types. What are data types? So data types are nothing but a way to tell a system what is the type of a value we are going to be stored. For example, real life example, if I say age is 25 is a number, right? So how do you tell the system that we have to store a 25 number? How do we do it? So basically all those things will be taken care by the data types. So the data types will tell the compiler, so this is the things, this is the type of the values that are going to be stored in that variable. So please allocate that much memory. At the end of the day, all the things which are stored will be stored in memory. Okay, for execution. So let's start talking so you will understand more about that. There are basically 5 basic data types. One is integer, char, that is a character, float, that is a floating point, double is also a float but with an additional what you get precise calculations. We'll talk about that when we come there. And we have void. Void means nothing. Nothing will be stored in that variable. Okay. So these are the basic types. Int is basically depending on your system. It's whether it's a 18-bit operating system or a 32-bit operating system. It will store the values. What is this bit and all? So let's study a little bit about the memory, right? So when I say memory, so let's consider this is a memory. Now you are running a this one compiler. Compiler has to store a values. Okay. So initially, at the end of start of the this one int, you are given int, and then later it will be modified. It doesn't know what will be the actual value, right? Currently, for the at the start of the program, int a is equal to 10. Okay, a's value is 10. We know that, but we cannot directly save 10 here. Later, the a's values might change to 100 or 200 in the program, depending on our case, right? So to solve the problem, we got the data types. We are saying int. So basically, what is happening here? Let me tell you. Let me take an example of 16-bit system. Okay, 16-bit system, right? What it will do is memory will be a 16-bit in columns like this. So your memory will be the zeros and ones will be stored. So if I correctly 1 0 1 0 1, let's save it as all as zeros first. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. This is your 16-bit machine. If you say int, for that int, okay, 16-bit number will be saved for that int. Okay, this much big value will be stored. So what is the 1 in binary? It's 0001, right? It will be stored like this in the memory. Okay, because it's a 16-bit machine. For 32-bit machine, there will be 32 digits. Okay, that is a simple math. Okay, so now then there, according to this is a limitation, right? So the systems will have limitations. That's the maximum number you can save, and the maximum number you can do this. Okay, depending on 62-bit, 62 depending on the int value, whether it's 13-bit machine or 64-bit machine. Okay, why zeros and ones? Because machine only understands zeros and ones. We studied in the basics, right? Zeros and ones will only understand it. Okay, so normally we don't talk about like bytes, every bit and all. So we normally say it as bytes. Okay, kilobytes, megabytes you heard, right? So normally it will be 1 byte is equal to 8 bits. This is general memory allocation things. So whenever if you are studying microprocessor or any processor, you will be handy with this, but we just have to remember as a programmer, this is we have to remember what is happening actually. So considering a byte for this, for 8 bit, it will be 2 byte of 4 bytes for it. Character will be only 1 byte. Now 1 byte characters. So characters are A, B, C, D, E. How we will store this? See, we said that the character is a 1 byte. That is a 8-bit bits, right? 0, 0, 0, 0, 0, 0, 0, 0. Correct? How? But how this we are going to store these characters here? Zeros and numbers. At least for numbers, we would have converted it into binary numbers, and then we have cut with it. But we don't have the binary numbers here, right? For this one, for those things we have ANSI values, right? So the characters are stored in ANSI values. For example, here's ANSI value is equal to is 65. Okay, 65. If you represent, it will be like this will be the value. And if I say in example in a program char put it in a inverted this one for characters, char x is equal to a, so a will be stored as this number in the memory. Okay, and this x will be pointing to this. Okay, so that's how it will be stored, and depending on b is 66, I think. So it will be like something like this for b. Okay, so that's how ANSI values. So if you want to know what is the ANSI, these are called ANSI values for this. Okay, so if you want to know ANSI values, what you can do, you can directly say, uh, you can directly if you pass x, it will print a, printf, percentage of t, you put x, it will print 65. So you can, to get the values of all these variable, each character you can do like this. Okay, okay, and for floats are numbers, pointer numbers. Okay, and depending on the point variables, it can value. So consider why there is a two different float and a double. So there's, it was for a simple reason. You know what is pi, right? That is the value of pi. 3.141. Correct. So for float, as it's a 4 float, if I say pi, normally, for example, float x is equal to pi, the x value will be maximum 1. It will not consider other values. For double, if I say double x is equal to pi, x will equal to 3.141 something goes on. Okay, so the precision when we do the arithmetic operations, the precisions normally what will happen, for example, if I am doing this float x plus x, okay, it will be 3.14 plus 3.14, correct. 4 4s are 8, 2 6 6.28. But similarly, if I do there might be a chance somewhere it become 5 5, right? The decimal will carry forward, right? This is not accurate value. Okay, the precision is less. The little difference will be there, right? So that's why they have introduced both float and double. If you want more precision is dot value, you have to go with float. And if it's okay for you and the numbers are very simple, the simple integers, then it's float. Normally you don't have to worry about double. Most of your programs will be using float itself. Okay, it's a simple mathematics program. Okay, and what is void? Void is a special thing, special data. Okay, which doesn't, what you say, which does not have any value. Okay, so normally a function, and normally void main. If you go and search many programs, they will say void main. Older times, nowadays void main will not be allowed. We will have to say int, but void main specifying that nothing will be returned back. Okay. Now, for example, why it is needed, I will say, let's say there is a function called int main, and we are calling it inside this. I will do some steps and I will display it. That's the end. Okay, and display. We have a display function. Its job is to display some value. Okay. Now, after printing, if it's if it is integer int, it has to return an integer. So normally, if you see return 1 will be there. Okay, so avoid writing return 1. What they have done is they are saying that it will not return anything. It is simply unnecessary to display, and here directly display. There is no, it will not be sending to storing to any variable or values. Okay, they directly do are calling display. That will directly execute. So that's why where the majority void is used. So these are the basic data. Now let's talk about type modifiers. Basic data type modifiers. These are called basic data type modifiers. We have 4 modifiers: signed, unsigned, long, short. What are the uses of this? Why we need this? Okay, so consider example of age. Okay, for human beings, for any, not for animal, for human being. Maximum recorded maybe around 115 or 120, but we say let's say 150. Let's give an example. It value may vary from 0 to 150. Okay, correct. 0 to 150. So considering 8-bit machine, let's consider an 8-bit machine. 8-bit machine. 8-bit machine has, okay, has 8 bits, right? Okay, 8 bits bytes and 2 bytes. So the first letter is always going to be used for your sign, that is positive or negative. Okay, you have remaining 7 digits. The maximum is here with the binary numbers. Maximum what we can get is minus 128 to 127 plus 27. This is the maximum range with the 8-bit machine for integer. For an integer age, if I give an integer age, then if 8 bits are allocated for this in an 8-bit machine, maximum values you can add is 127 to 120, 1 to minus 128 to plus positive 127. Now, as our assumption, the maximum allowed value we think is going to be 150. That is the maximum thing, but it doesn't support this, right? What we can do? Okay, there are many things we can do using this type modifiers. So let's see what we can do. So here looking at this age is never going to be a negative value. The war started, right? It's never going to be a negative value. We don't need this negative ones, right? Okay, we don't want to represent a negative value. Okay, so what we can do is we can say we don't want negative value, start from 0 to the value. How we can tell that? To understand this, we have to understand how the negative values are stored, right? How the negative values are stored. So, consider an example 5 and minus 5. How these both are stored. 5 will be stored as, for 8-bit machine, 0, 0, 0, 0, positive, 0, 1, 0, 1. This is the positive number. This is how the 5 is stored in an 8-bit machine. The negative one is going to be same as positive, okay, same as positive. We have to make it 2's complement. How is making it 2's complement? 2's complement is nothing but first we have to reverse it. 0 becomes 1, 1, 1, 1, 1, 0, 1, 0. Okay, then we will add. This is the 1's complement. Now we are going to add 1. Okay, this is 2's complement. This is your minus 5. Look how it is stored. The 5 is stored like this, minus 5 is stored like this. Okay, how the system will come to know which one is a positive number, which one is a negative number. That's why the first digit, I told you, right? The first digit is used to recognize whether it's a positive or negative. If 0 is coming, that's why it is a positive. Here 1 is coming, that's why it's a negative. Okay, so this is how it's been happening. When you directly declare int, the first digits will be reserved for your sign, this one, whether it's a positive or a negative. Okay, now let me see. As age is a positive number, we can tell the system that we are always going to give a positive number. Okay, so where, to understand that, we have to register where this range is coming from, right? This range is coming from leaving out this one, right? So now I even this value is not needed because we already know that every value is going to be a positive one. Even we don't need the specifically tell us it's a compiler that first value is going to be a positive or negative. So we can use this. Okay. So how to tell the compiler use this is to use this top modifiers. Okay. So if I say unsigned int age, okay, the allocation can now go up to, we have 8, so now some value. Okay, now the allocation can go up to 0 to 255 for an 8-bit machine. Remember, I am doing for 8-bit machine. Okay, for just to easily explain, I am going to the 8-bit machine. Okay, so we solved a problem just by modifying the basic data types. We were able to solve a small problem about age. Okay, that's where unsigned modifier. So these are the examples. These are why the modifiers are used. What is signed? Signed is nothing but a simple integer where signed is going to be either signed or positive or negative. It will always going to say positive or negative. By default, integer is a signed one, is equal to signed int. By also, it's going to be a same thing. It's going to be a signed int. Okay. For unsigned, you can specify unsigned or unsigned int. Okay. Both are same. You understand what are signed and unsigned, right? Signed is nothing but they will have signed value. Okay. Unsigned is unsigned. I just explained for age the example. Now we have a long. What will long do? Okay, so what is long then? So consider a 8-bit machine. So we had a similar issue, right? For 8-bit machine, if I give the integer, it is a signed integer. Okay, so our range is minus 128 to plus 127. Okay, if I mention it as long int, what it will do is it will have, currently the int has 2 bytes, right? 0 0 0 0 0 0 0 0. If I put long, okay, another additional 2 bytes will be added to that memory. Now initially we had 8 bytes, right? Now with long we are extended to 16 bytes. Okay, okay, so 8, sorry. Okay, so let's talk about this, how the long way works. So this is one example how the long way is going to work. Actually, by default, we are say byte, right? So it will be a 4 bytes. Okay, that's how the long will work. So if you're pushing for long in for 8-bit machine, it will going to be 8, the normally were 8 bits. Okay, so say byte byte 1, byte 2, byte 3, byte 4. So that's 8. The total that will going to be 32-bit machine. 8 fours are, this is an 8-bit, this is an 8-bit, this is an 8-bit, this is an 8-bit. 8 fours are 32, right? So you are converted now using the long, you are converted a 8-bit memory location to a 32-bit memory location, which can do lot of calculations used. Okay, that's the use of long. What is short? Okay, same thing. For if something is very short time needed, so let's go back to the our age example for 16-bit machine. Okay, age example, if age is given in a 16-bit machine. 16 will have 4, 16 bytes allocated, memory allocated in the age. But our range is between 0 to 150, which we can easily do in this, right? Okay, that's where we go with short int age. So instead of giving it all the memory, we are saving the memory here. Okay, that's how this short, signed and unsigned, long and short are type modifiers which are used. Basically, that's how the memory management happens for this. Okay, remember that int we can be paid. One more thing to remember, int can be paired with all the 4. Char will paired with, for float we don't have any modifiers, we don't use. For double we can only use long. Okay, and in C99 there was, we can also use long double. It's going to be very large number, just imagine. Okay, now void is one thing, but that's why there is no type modifier. So basically, so this is the basics of things for data types. We have 4 data types: int, char, float, double, void. Int for integers, char for character, floating numbers, integers. Double is also in integers, floating numbers, which more precision than float, and void for nothing. Okay, and these are basic data types which can be modified as signed, unsigned, long, short. Okay, with respect to 32-bit, I will post a page where you can see all the values. What is the address values, minimum range? We were talking about range, right? The same range for all this with the 32-bit machine. Okay. These are the data types and their modifiers with their range. Thank you for watching. Please subscribe.